All right, here we are, part B of question number 12. Now we're moving on into the titration, and we've added 10 milliliters of the sodium hydroxide. What's challenging here is that you have to be able to wrap your head around what's actually going on as far as the chemistry is concerned. And that means writing down the reaction of benzoic acid with sodium hydroxide like I've done here. Benzoic acid plus sodium hydroxide yields benzoate plus sodium ion plus water. And so what we need to be able to realize is that having benzoic acid and benzoate in the solution means that I've got a buffer that's going on, and so that I can use the Henderson-Hasselbalch equation in order to figure out what the pH is. Here's my conjugate acid. I need to figure out the moles of that, and there's my conjugate base. I need to figure out the moles of that. Now, in order to do that, we can start off by saying I had 100 milliliters of the 0.2 mole benzoate, my hypothetical acid, and that means I had 0.002 moles, 0.02 moles of HA. And I can do the same thing for how much of the sodium hydroxide I added. I added 10 milliliters of 0.4 molar, so that means I added 0.0400 moles of the sodium hydroxide. Okay, here's where things start to get tricky. What does it mean to have added 0.04 moles of sodium hydroxide? Well, for every mole of sodium hydroxide I react 1 mole of the benzoic acid. And so that means I reacted 0.00400 moles of benzoic acid. It's gone now. Okay, well, what do I do with that? Well, if I started out with 0.02 moles of benzoic acid and I got rid of 0.004, that means that I have 0.016 moles of benzoic acid left. All right, so now what I need to do, if I reacted 0.004 moles of benzoic acid, then by the same stoichiometry in the same equation, that means I created 0.004 moles of its conjugate base. And those are the two pieces of information that I need in order to sort out the information from the Henderson-Hasselbalch equation. I'm given the Ka, and those two pieces of information go in this ratio. I had 0.004 moles of A minus and 0.016 moles of HA. And I showed you before how you can use moles instead of molarity, but you can certainly have used molarity here. You could have even used an ice table and solved this problem with an ice table, and you'll get the same exact answer. But starting to simplify, I get pH equals 4.2 minus the log of the ratio, which is 0.6. And so I end up with pH equals 3.6. And that's the answer for this section.